Hi students, in this session I am going to take about the uh, stream function and velocity potentials and also the flow nets. We will see the things one by one. The topics I am going to cover this are the stream, what is the stream function, and what are the mathematical foundations which are involved, and also the flow net properties and the velocity potential, then flow net construction, the step-by-step methodology, and the applications in the civil engineering, and some examples and also the problems. So some cases we will see that. So first you should know that what is a stream function. So it is a scalar quantity. So I think you know that what is the meaning of scalar quantity. So here if it is the continuity equation which is satisfaction, that is a dou u by dou x and dou v by dou y. So that is a variation of velocity, summation of the variation of velocity in x and y direction is 0, and also if I am taking for a 3D flow, where that the velocity u is nothing but dou psi by dou y, and the velocity in y direction I am taking that as a negative derivative of dou psi by dou x. So next if I am taking that the mathematical foundations. So for if it is a streamline, we are representing by the letter psi, and dou psi is nothing but the it is between the streamlines and also it is equal to the flow net. So where that velocity component we are taking as u and v. So u is nothing but dou psi by dou y, and if it is the velocity in y direction is negative derivative of dou psi by dou x. So it is a uniform flow. The psi will be uy, and if it is the source of flow, for a source of flow the psi will be m by 2 pi of theta. So, and if I am taking the velocity potential function, it is a scalar quantity for irrotational flow. So, we are representing by the letter phi. So, the velocity is a gradient of potential, and we are taking that v equal to delta phi, and if it is for 2D flow, the velocity in x direction will be dou phi by dou x, and velocity in the y direction will be dou phi by dou y. So if it is satisfies the Laplace equation, the delta square phi equal to 0. So here it is only valid for the irrotational flow. So for irrotational flow, only this velocity potential function will be valid. For the other types of flow, it is not valid. And the next one is if I am taking that the mathematical equations which are involved in the velocity flow is the Laplace equation. Already we were discussed, that is a dou square phi by dou x square summation of dou square phi by dou x square plus dou square phi by dou y square equal to 0. This is a Laplace equation. So whenever if I am taking the uniform flow, the phi will be ux, and the source flow, the phi will be m by 2 pi and logarithmic of r, and for this the Cauchy-Riemann equation. So the derivative, that is dou phi by dou x equal to dou phi by dou y equal to the both are equal. Okay. So here whenever if I am taking that orthogonal property, always the streamline and streak line will be perpendicular each other. So you can see that the streamline and a streak line. So these lines are perpendicular to each other. So whenever it is perpendicular to each other, so this, if it is intersecting, it is called as a flow net. So what is a flow net? This is a graphical representation of 2D steady flow. So if I am finding this property, the stream function and velocity potential function. So if I am drawing the thing, so these are mutually perpendicular. So whenever if I am drawing, if it is like this, we are calling that as a flow net. Okay. So here the flow networks, the networks of line will be, if I am taking the streamline, the curves tangent to the velocity. If I am taking that, the curves, it is a tangent to the velocity, and if I am taking that, the equipotential line will be different. So what are the properties? Okay, and in construction. So these are always the streamlines and streak lines are perpendicular to each other, and it is there will be the curvilinear squares, and forms square as possible. The flow net diagram, if you are drawing the flow streamline and streamline, so there may be the that forms square. Okay, so we are calling that as a curvilinear squares. And the constant flow ratio, the ratio of flow channels constant throughout. And where it is used, so it is used to draw boundaries, sketch few streamlines, draw equipotential line, adjust for orthogonality, and redefine the net. So this is the methodology for drawing the flow rates. And where it is used, so wherever, if we are analyzing the seepage under the dams, so here whenever if you are taking the seepage dams, there will be the water is stored for a year. So therefore there may be the chances of seepage will be there. So we have to understand the seepage analysis. For this purpose we are using the flow nets, and also to monitor the groundwater flow. So and for if you are modeling by software, where this flow net is important. And also the well flow analysis, and whenever if you are designing any hydraulic structure, for an example dams or reservoirs, and also whenever if you are constructing any underground structure, we have to analyze and we have to study the uplift pressure acting on that. So where we are using this flow net, and also the if you are doing that, we can avoid the piping, and the failures due to piping can be avoided. And if you are taking some examples, the equations, the flow rate calculation, the seepage velocity, and the pressure distribution, and the best example is seepage under the concrete dam. This is the topics you have studied. So we have studied the what is the streamline and streak line, and how the flow patterns are there, and how we are drawing the flow nets by using the streamline and the velocity potential thing. So thank you for listening this video. Thank you.